coming to a component that you typically don't see in operation. But if it fails, the turbine won't run for even a few seconds. That is the bearings. Bearings are what support the rotor and keep it perfectly aligned while it spins at very high speeds, often 3000 or 3600 RPM or 6000. So think of it this way. You have a massive rotating shaft carrying heavy blades spinning continuously without proper support and alignment. So that system would become unstable almost all instantly. Now, the type we commonly use in steam turbines is the journal bearing, which provides radial support. Unlike rolling bearings, these are hydrodynamic bearings, meaning there are no balls or rollers inside. So how do they actually work? They rely on a very thin film of lubricating oil. As the shaft rotates, it drags oil into a small gap between the shaft and the bearing surface. So this creates a pressure wedge of oil which actually lifts the rotor slightly. So during normal operation, the shaft is not touching the bearing metal at all. So it is essentially floating on oil. So that's what allows smooth rotation with minimal friction and wear. Now, if you look at the image, you'll notice two important elements: the lube oil port, which supplies oil into the bearing, and the bearing pads lined with that we call white metal or Babbitt. So this white metal lining is very important. So it is designed to adapt to minor misalignment, absorb small particles without damaging the shaft, and also provide a smooth, low friction service. But here's the key point: this entire system depends on the clean, continuous oil flow. If lubricated is lubrication is compromised, the oil film breaks down. Metal to metal contact begins. Heat builds up very quickly, and this can lead to bearing failure within minutes. That's why lubrication systems are treated as critical systems in any turbine. Also, not all journal bearings are the same. Depending on the turbine size and operating conditions, you may see simple sleeve bearings or most or more advanced designs like tilting pad bearings, which improve stability and reduce vibration. So, to summarize, bearings are not just support components, they are what enable smooth, stable operation. They carry the rotor load, maintain alignment, reduce friction through oil film lubrication, and most importantly, they protect the turbine from vibration wear and catastrophic failure.